Hello everybody. I'm going to start this stream sooner. I will start stream soon. So I hope you guys can wait for me. So thank you so much for your patience and for your cooperation. Thank you. I'll be streaming soon. So yeah, just get ready. Hello everybody. This is Suguwa, and today, let me see. I'll reset again. Alright. And today I'm going to, I mean, how do I say? Let me come back with proper introduction. Okay, so hello everybody, good morning, and I'm Suga, your host for today's launch commentary here. Okay, and today it's going to be launched for the Atlas 551 rocket configuration with the ViaSat-3 Flight 2. Yeah, we are going to witness today we are going to witness a pretty historic moment where this is going to be the last time ever that Atlas 5 rocket will go beyond the low Earth orbit. It's going to go to geostationary Earth orbit, as you know, because Viasat is, yeah, of course they are going to put their geostationary satellite here. But instead of say this one previously allocated for the Europe, if I remember correctly, now they are going to reassign this flight to the Americas, while the flight number 1 previously launched on 2023 on board the SpaceX Falcon Heavy rocket. Yeah, I hope I can stream Falcon Heavy even just once at some point, because I missed a lot of good things there with that. Okay, so because the flight one does have the antenna transponder problem there. It only can just it can only just, how do I say, just beam out around 10% of the planned total full capacity, around only 100 gigabits per second of total maximum theoretical bandwidth, in comparison to the 1 terabits per second. So basically what ViaSat will be doing is that once the flight 2 already positioned itself to the almost similar to around the where flight 1 right now being right now, the flight 1 will be relocated back to the Asia region. Yeah, so that's the only thing that ViaSat can do. And also they do a little bit like some compensation, monetary compensation and whatnot. They got the space insurance, if I remember correctly, around six. Let me see, because I'm not going to make up my own source. Oh, no, it's not 683 like I said that morning. It's 420 million US dollar space insurance coverage. And yes, nice number. Am I right? Okay, so that's basically it. Because of that, and they got their claim around the end of the 2023, of course. So that's how they actually able to do that. And looks like while we are still waiting, why not we cover a little bit things about this flight mission? Okay, maybe just give me a little bit of time. Yeah, because sometimes for whatever reason, internet sometimes did not cooperate properly, so bear with me, even though upload looks fine. So okay, is it okay though? I think I'll put on the full page here. Okay, so this is a full page, and let's go. This is how the mission website looks like here. And yeah, it says that Atlas 5 to launch ViaSat-3 Flight 2. And yeah, they are going to launch this one, and then it's going to be the double. Oh, so Flight 2 will be, yeah, would be the double the bandwidth capacity of ViaSat's entire existing satellite fleet. And yeah, the launch date and window is around right now. How do I say, because the conversion would be, oh, okay, looks like they still updated as of now. Okay, the launch date and window, at least in the US, around the Eastern Standard Time, will be on 13 November 2025 between 10:04 until 10:48 p.m. there, Eastern Standard Time. While on the UTC, the Universal Time Coordinate time, it will be on 14 November 2025 around 3:34 until 3:88 a.m. And here in Sarawak, it will be the time here also will be the same. The date also would be the same as the UTC, 14 November 2025, with the launch window of 11:04. Yeah, 11:04 until 11:48 a.m. In the morning here. So that's why I still can stream, and why you see I'm doing it to be simultaneously. So here we go. All right. Okay, so looks like okay, looks like at least for now, where is it? Okay, so the upgrade itself, it's already there. Okay, so according to the how do I say, how do I even get this started? Okay, this one is the updated mission profile here. If you want to see, it's also available. Wow, they actually really cares about this one. So if you would like to read entirety of this, I recommend you to go to this website. Let me go to my live stream and you can check it for yourself here. Okay, so you can kind of click there. Let me go back. Okay, so you can see there they have their own mega ships handling, and they already done their engine chill down and whatnot. This is plus minus what you can expect. Yeah, there's a lot of update here. I'm not going to bore you too much because this is what's happened before. uh, yeah, it's going to fry my brain if I try that I just go cover too much of these, but I'll explain a little bit later here. By now, it's all of the propellants, both of the first stage and also the second stage, um, or second stage, basically the upper stage, already done, already fully loaded. Okay, and here you can see this is the ViaSat-3 flight number 2. How it looks like, there's like a big, how do I say, big, like a big circle there. That one is actually the antenna, the inflatable antenna, if I remember correctly. Yeah, and it can deliver more than 25 kilowatts of power. In terms of that, yeah, the ranges are pretty important. I mean, if even if slightly you learn about this stuff, the power generation is pretty important to in order to overcome the signal of overcome the interference signal and what's on. So that's why it's very important, and also to raise up that SIR ratio, the signal to interference ratio there. The higher the number, actually the better, because the signals getting more clearer compared to the interfered signal if you try to broadcast it. Okay, so, and yeah, it says dynamic beam forming. I mean, if you guys even know about this definition, I mean, some of you might really learn this. I do personally learn a little bit of it. Not like I want to say I know about this topic 100%, but in our computer science course, in my computer science course, I actually learned about this stuff. Beamforming is basically like, how do I say, like, try imagine you try you it's try imagine it's like you're trying to use some magnifier glasses, okay, but instead of just using one magnifier glasses, you just put a, a, a stack of how do I say, magnifier of it, and you focus into one or another few more places that's still within the range, okay, to increase the power, the signal that can be moved there. So that's basically the beamforming. Also also the beamforming itself actually already being in use in technology right now, especially for example the 5G technologies, yeah, already in use. So that's that, and it's going to be the satellite mass itself, obviously it's going to be 6 metric tons, or around like that. Okay, apparently it says that expected download speeds theoretically maximum would be around 100 plus megabits per second. I mean, it's okay, I'll say, because how do I say, we do have, at least here we have some we have our own local ISP here, but mostly from what I know it's the TM1. Okay, they actually have some the unified plan subscription here. That one is how much cost it nowadays. It's not really that super expensive anymore. I don't know, maybe between 89 or 129 ringgits, or around, if you change this into dollars, it's like 20 plus US dollars, or around 30 plus US dollars per month, like that. Basically 100 megabits per second. I mean it's not bad if you're using this 1-2 devices, but if you need to use a little bit more, you can just bump to 300 plus megabits per second. So yeah, that's what I used back then. I used that 300 megabits per second tier back then, before I had to rely with my phone. It's a cellular phone. But yeah, I guess life is good. I guess so. That's that. Okay, and where do? Okay, by now. Oh, yeah. Okay, so looks like they already start their stream. Okay. Okay, so ouch, stream doesn't doesn't looks good, but however it's fine. Okay, let's relax a little bit. Maybe I'll see what's happening. All right, nice, nice, nice. All right, so looks like we have already fixed a little bit of problem here. Okay, and now we are at t minus 80 minutes and 80 minutes and 16 seconds. Yeah, I just want to say 18, 18, 18 because good number, why not? Alright, so I guess here you go. Rather than covering too much, I'll just do okay, might as well just cover like this a little bit, I but just to say in the nutshell, for the first stage booster, it will be using one it will be using one RD 180 rocket engine, but it has like two nozzles there. Because you want to know something, RD 180 the engines, it's basically the cut down version of the RD 191 rocket engines, and this one actually powered by the Carolox propellant, basically liquid oxygen as the oxidizer, and super refined kerosene as the RP1 as the fuel itself. Basically, the super refined kerosene, it does have as little to no lead contamination or basically any other metal contamination, because remember when it actually uses these rocket engines, it's going out from the rocket nozzles pretty fast. We are talking about how many kilometers per second? Around 3+ kilometers per second, and even inside the combustion engine before it reaches that throttle which indicates the supersonic, okay, or sonic speed, Mach 1 there. Inside there, it's like subsonic, but it can be pretty damaging because it's so hot and it's a lot of particle inside there. That's basically like super hot plasma from the burn field there, that if there's too much contamination there, it's going to destroy the combustion chamber, maybe even the turbo pump itself. You need to remember it's pretty sensitive to this one, so if it's not refined in the first stage, it's not going to be pretty good. Okay, so that's why. Okay, yeah, I mean, I'm sorry. Yeah, maybe you can hear this. Okay, yeah, so sorry. I botched on this side. Okay, I accidentally closed my my laptop, and unfortunately it doesn't have any batteries here right now. But yeah, wow, I really messed up pretty big there. Oh, I'm sorry guys, I'm very sorry. Regrettable. This is my fault here. Very sorry. So okay. Oh my goodness. My goodness. Oh no. What am I doing? Fortunately, I can put this up pretty quickly here. Oh, that's a little bit harrowing. Okay. Okay. Give me a little bit of time. I'm not going to talk too much here. Okay. My mistake there. Very sorry guys. Very sorry everyone. Very sorry girl. And literally everyone. Sorry. I accidentally closed it. I supposedly should have just closed my phone's charger, but man. Okay, I think you should be able to hear the desktop audio here. I'll open it again. Okay, come on, come on, come on. Very sorry. Uh, but I hope you guys didn't tune this out. Okay, because this is obviously my fault. I just closed my laptop's charger. Technically not laptop's charger. It's just a power wall at this point, since the battery's already died. What? Okay. 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 So
Centaur releases the
alright.
ViaSat-3
So
F2
looks like it.
satellite into geosynchronous transfer orbit, or
We are back
GTO,
again.
to expand
We are
and
back.
enhance in-flight connectivity for aviation passengers, exceed performance, security, and resiliency for governments, enhance internet experience on board vessels, and help deliver fast, reliable internet to rural communities.
This is Atlas Mission Control at L-9 minutes and 31 seconds.
All
On your
right.
screen now, you're looking at the flight configuration key for today's mission.
Alright. So we are back again.
AV-551.
Huh.
AV stands for Atlas 5. The first 5,
Okay. So
the middle 5 is for the number of solid rocket boosters, which is fully loaded today at 5. And the singular 1 on the end is for our Centaur engine.
alright. So yeah, I'm pretty sorry there, guys.
Now that we've seen the flight plan and
My
learned about
apology.
the configuration,
My apology
viewers
for
watching from Florida and parts of the
for
southeast may
for
be
that.
able to see your
It
Atlas
should not
rocket in
happen,
flight.
but it
To get a
happened.
closer look at this visibility map, check out at
Yeah.
ULA launch on social
But
media.
but I guess it's better to happen before the launch than actually while the launch itself. So yeah, what I'm going to say again. Everyone,
As we approach the opening of our launch
okay, a
window,
little bit
let's have a
better.
look at the weather
T
forecast
minus
our launch
8
team
minutes
just
and
received from Space Launch Delta
36
45's
seconds.
weather
Alright.
officer, Brian Sizek.
might as well I just grab
Today's
a little bit
forecast
of
for launch is looking good. The probability of violating
chocolate
launch is
drink
less
here.
than 5%.
because
The
it's good.
ground winds
So
are 5 to 9
I'll be back
knots
again.
out of the north direction, and the temperature is 62 to 64 degrees Fahrenheit. There are no concerns for launch, and the weather is looking beautiful.
Go.
Okay, so
We
you,
remain in the
you-
planned
so
30-minute
you know
hole
why
as we
I
continue
didn't talk
towards
right now.
liftoff. In a few moments, ULA launch conductor Ed Kidda will pull the team for the final go to pick up the countdown. The launch conductor manages the launch team during the countdown, ensuring that all systems are performing nominally and that every member of the team is following their procedure and executing per the planned timeline.
28 engineers are pulled to confirm the rocket is ready to proceed. This is the final status check for all Atlas vehicle systems, ground systems, the payload, and the
Oh, right. So I've already back again. Oh,
United States Space Force Eastern Range. Let's listen in.
all right.
Pneumatics. Go.
Okay, so
Hello
this is
two.
terminal
Go.
pole countdown
Water.
here.
Go. Centaur systems.
Okay,
Propulsion.
right?
Go. Pneumatics. Go. LO2.
Go.
LH2.
All
Go.
right.
Has gas.
Go.
Electrical systems. Airborne. Go. Ground.
Oh, nice.
Utility.
Go.
Go. RFFTS. Go. Flight control. Go. GCQ. Go.
Yes.
Op support.
So looks
Go.
like everything is go.
Go. Umbilicals.
Go.
Environmental control systems.
Go.
Okay,
Redline monitor.
go.
Quality.
Go.
Op safety manager. Go.
Mhm.
ULA safety officer. Go.
Okay,
Vehicle system
for
engineer.
left here.
Go.
Okay,
Downlink
3
sheet.
down,
Go.
2 down,
Range and weather. Go.
Okay, one left.
You have permission to launch.
Alright, so this is it. Very good signal there.
With the count.
So we are proceeding with the countdown.
Polling is complete, and the team is go for
And
launch.
yeah, I need to
Now until
quickly
liftoff,
mention to you that
launch conductor Ed
RB-180
Kidda and the launch
rocket
team will
engine is
continue
it's
reporting
basically
the final steps in today's
a single
countdown.
combustion
This
chamber
includes
engine
verifying
with
propellant levels
two
and pressures in the
rocket
booster
nozzles
and
there.
centaur fuel tanks,
Basically,
as well as
also
arming the
derived from
ordnance
the
system for ignition, separation,
RB-191
and
rocket
flight
engines there,
termination.
a
At T-1
cut-down
1
version
minute,
of
the
it,
range confirms
with
it's in a
4
green
rocket
condition for
engine
launch,
with
assuring
the
there are no nearby constraints like
RB-191.
boats, planes,
That
or
one,
weather,
that one
and all
originally
tracking
been
systems are operational.
used for the
At T-minus
Soviet
25 seconds,
short-lived
you'll hear Go
space
Atlas,
shuttle
Go
program,
Centaur.
the Buran space. So that's that. Okay, and it's obviously powered by the Kerolox itself, Kero's propellant, which liquid oxygen as the oxidizer and super refined kerosene as the fuel itself. Oh, you're still stuck here. Oh no, what's even happening?
And flight termination.
Okay,
At T-minus
So,
1 minute, the range
fortunately
confirms it's
it
in a green
works.
condition for launch, assuring there are no nearby constraints like boats, tracking systems are operational. At T-minus 25 seconds, you'll hear
Okay,
Go
so-
Atlas, Go Centaur, Go ViaSat.
so yeah,
This is the final status check for the rocket and
visit
payload.
To dampen
one-
the acoustic shock at
one of
liftoff,
my
at
friends
T-minus 6 seconds,
of this
the launch
channel
pad's water deluge system
get blocks
activates,
worthy.
followed a few
So,
seconds
yeah.
later by boost Centaur ignition.
Oh,
Then,
alright.
after seeing Atlas
Alright, so why not? Why not? Let's go, I'll put on the display. Okay, let's close a little bit. No. I don't think internet is very cooperative right now. I don't know what's happening. I have no idea. But let's hope for the best. Okay.
liftoff, you'll hear flight commentator Daniel Brunson providing updates as the rocket ascends into space.
Okay.
One of the topics
That's
circling around
good.
recently
Back in the live.
clock has resumed and we are go for launch at 10:04
Yeah.
p.m. Eastern. While the countdown
Oh, alright. Oh. Looks like I've already overboosted. That's why. Sounds pretty. Yeah. Yeah, so. Yeah. So let's say hi. We are live. Because why not? Let's say hi to.
continues,
Go and visit
let's
her
learn more
here
about how
too.
ULA builds the Atlas V rocket.
Oh no, no. Oh my goodness, where is?
Engineered in Centennial, Colorado,
There is one. There is one. I guess. Let's see. I don't know. It's a jumbled mess. Yeah, so let's do a little bit raiding, aka infiltrating the stream here. So yeah, very sorry. It's not really stable, but okay. But I guess that's all. We just go instead to the live. Okay, I don't have too much time. Let's put it
Clock has
here.
resumed and we are go for launch at 10:04 p.m. Eastern. While the countdown continues, let's learn more
All
about
right.
how ULA builds the Atlas
So
V
here we
rocket.
go. This how? Oh no!
rocket, as well as
It's so
backup
slow.
generator. Atlas arrives at the pad for fueling
Okay. I don't know what's
and
happening,
other
but
final preparations. And once fueled, weighs nearly 1.3 million pounds.
okay. So here we go, and yeah. Oh,
137.
I'm curious. Why suddenly
MTS.
the change of quality?
T-minus 90 seconds. The launch
So
vehicle,
far.
ground systems, payload,
Okay, and
Eastern
I
range,
can give you a
are go
little
for
bit of
launch.
briefing. There's going to be a 5 solid rocket booster there, hence why it's called as 5 in the middle 5-2.
At this
1.
time, the team
Okay,
is
that
not
5
working
in the
any
middle
issues, and we are
designation
proceeding towards
is
liftoff
5
at
solid rocket
10:04
boosters
p.m.
there.
Eastern.
If I remember, the left side it has 2 solid rocket boosters, and while on the right side has 3 solid rocket boosters. And on the central upper stage,
T-minus
it's going to
1 minute.
be that one is basically powered by the hydrolox propellant, which liquid oxygen as the oxidizer and liquid hydrogen as the fuel. Pretty cold, very in fact super cold for the liquid hydrogen. It can just transfer some of that cooling to the liquid oxygen. Of course, it cannot mix propellant, but it can somehow bleed a little bit bleeding mix for the cooling. Okay, and get ready. We are going to launch.
28.
28 seconds.
Launch.
Okay, getting ready.
Status check. Go Atlas.
Okay,
Set talk.
go Atlas, go Centaur, go ViaSat, and we are ready to go. Let's go, everybody. T minus 10, 9, 8, 7, 6, 5, 4. Okay, you can see RD-180 engine ignition. Getting ready. And ready, ignition. Okay, and SRB, all 5 SRB is ignition and lift off. And you can see it's pretty fast lift off there from the Slick 41, Space Launch Complex 41 on the Cape Canaveral Space Force Station. We have liftoff for the Atlas 5 final launch to the geostationary Earth orbit and also basically beyond the low Earth orbit. So here we go. It's pretty nice there.
Mach 1.
Alright, Mach 1, it's already gone into supersonic, and by now RD-180 rocket engine has already been throttled down to 60%.
Daniel Brunson.
Okay, max Q, maximum aerodynamic pressure, fully exerted on the launch vehicle in accordance to the launch vehicle velocity and also the atmospheric pressure there. If there's reaching one point, it's going to be a max pain for this rocket itself. And after the max Q, the RD-180 rocket engines will be going to 100% again, or maybe 80 sometimes. Okay, getting ready for the SRB burnout, all of it. Okay, so here we go.
At this point in flight, the vehicle is now half of its original liftoff weight.
Okay, looks pretty good. Getting ready at T plus 1 minute and 46 seconds will be the SRB jettisons, as the SRB needs to separate according to the safety range and also due to the thrust residue. Okay, and right now, getting ready, and that's it, SRB jettison, the SRB side rocket boosters jettison. Okay, finally separated, and now RD-180 rocket engines.
These additional motors augmented the thrust at liftoff to give the Atlas V rocket an extra boost to reach geosynchronous transfer orbit.
We're coming up on our next mission event, jettison of the payload fairing. Let's listen in.
Okay, and let's listen in for the payload fairing jettison. Okay. Alright, and now at T plus 2 minutes and 28 seconds. Okay. Getting ready for the payload fairing jettison there. Okay, as you can see here, the exhaust plume here is getting wider and wider and wider as it's reaching to the vacuum condition in space, and as there's almost no atmospheric pressure to keep hold of that very super fast rocket exhaust plume there.
Now we've got activation of the second stage RCS system.
Okay.
Hydrogen coming up to flight pressures.
Okay, that's what we heard, and getting ready for the payload fairing jettison, and as it no longer being bounded by the atmospheric pressure, of course it's going to expand to the point where okay, getting ready for payload fairing jettison. Should be separate by okay, payload fairing jettison, as you can see there.
Daniel Brunson just got out confirmation of payload fairing jettison. The payload fairing,
Oh,
commonly
right.
referred to by many experts across the industry as the pointy end of the rocket, serves to protect the spacecraft from those harsh acoustics and aerodynamic forces as it's essentially
Yeah,
the thicker
and
piece.
also if you notice,
Absolutely, the payload fairing
inside
also helps
the
protect from
payload fairing
thermal
itself, it does
environments
have a
and
little bit
environments as
of
well. Up next, we'll hear callouts for cutoff
Oh.
of the Atlas first stage engine and separation of the
Oh,
booster
downrange?
stage,
That's
followed by ignition
even
of the
worse.
ULA Centaur second stage engine.
Oh.
Let's listen in as we approach these milestones.
Oh,
And we've begun boost phase chill down of the upper stage engines.
Okay, so I think we can scale down this a little bit there, so you can read the indication. Okay, and I've already make it easier. Okay, very sorry. Okay, so here you go. The
And we completed boost phase chill down.
okay, already completed the boost, the
And good check.
upper stage
Let's be go.
chill down. Okay, and booster engine cut off on the
Good
first
indication
stage.
center separation.
Okay, and get ready. Oil separate and
Restart on LO2 and LH2.
okay, get ready. Pre-burn start on the second stage, the Centaur rocket engine there.
Ignition.
Okay, and
And full
ignition
thrust.
and full thrust.
This is Atlas
Centaur's
Mission
enabled
Control.
steering.
Yeah,
T plus 4 minutes and 52 seconds.
yeah. If I
Just
remember
heard flight
correctly,
commentator Daniel Brunson confirm
this
the
one
successful
technically
completion of
isn't
the early milestones in today's flight. and all
technically
systems
isn't the
continue to operate
open. How do
nominally.
I say?
We have about
Not a
6.5
gas
minutes
generator
until we
rocket
reach our
engine. If
next
I
mission
remember
event,
correctly, this
shutdown
one
of
is
Centaur's
around
main engine.
type
We'll
of
return with mission commentary
stage
as we get
combustion.
closer
If I
to that
remember
next
that, hence
milestone.
that's why you can see there's like slight piping out there. That one is actually to move the turbo pump there. Okay, at the right side pointy end of it. Okay, and right now almost 6 minutes into the flight, and now T
This
plus
is 6
5 minutes and
remains.
35
First lane
seconds.
burned.
Okay, and this is it.
CS thermal conditioning firings continue.
Alright,
Hydrogen
and
line
looks
temps
pretty
remain
good.
below throttle temps.
Alright. Alright.
Vehicles approaching 700 miles downrange, 28 miles in altitude.
Alright. So here we go. It's looking pretty nice and pretty beautiful. And T plus 6 minutes and 6 seconds into the flight. Okay, right now the altitude right now it's already 200. Let me try to see. Okay,
Centaur
around
used on to cruise
213 kilometers of altitude and velocity is 6 kilometers per second. And downrange is almost 11, almost almost 1200, almost 1200 kilometers downrange there. And looks like it's already switched down there. Okay, to show us the indication. The perigee altitude, the lowest point, lowest orbit point from the Earth, and also the apogee, the highest uh, point altitude from the Earth. Okay, and looks like you can see.
Data format. Signal
Uh,
strength continues
Okay,
nominal.
and you can see there's a little bit slightly hot glowing right there, right? That one is really how much power you can get inside the Centaur upper stage rockets there, you know. You can see there. This one is powered by the RL-10C rocket engine there. There,
Vehicles now
if I remember
1,030
specifically,
miles
one
downrange.
dash one.
Continuing
Yeah,
right down the center of the range.
there's a lot of production unit there, but that's the only thing you need to know. Okay, and looks pretty good there. For the ViaSat. Alright. Yeah. I mean, we are slightly chaotic there in the beginning because
Engine
a little bit
parameters continue to look healthy.
stream shut down for a few minutes because I unintentionally turned off that my laptop's power brick there since the battery has already died. I suppose they should have already closed the phone charger, but well, it's fine. It's totally fine. And to the new and existing viewers, hello and welcome. And also even to the replay viewers, welcome too. You're very welcome to watch this stuff. Okay, it's pretty interesting.
And hydrogen line temps have confirmed
Even though
thermal
for
temps.
now we don't, they didn't use the onboard rocket onboard camera
Temps
there.
remain in the
Yeah,
first burn.
it's using the, how do I say, using the real-time animation here, so you can see what it's doing. Even the RCS, the reaction control system thruster, opens up some of it to orient the rockets itself to the correct position and also to deliver the satellites into the correct
Vehicle
orbit
approaching
and whatnot.
150 miles downrange, 145 miles in altitude.
All right, so
Engine parameters continue to look healthy.
but even though it's using Imperial, but just but whatever it's even I can't totally translate myself properly there. Okay, and looks like the apogee altitude kilometers by now already in positive 200, around almost 220, 231 kilometers, while the perigee altitude
2
kilometers
minutes, planned MECO.
it's on negative, but it's soon going to get that out pretty quickly, and going and right now going sub negative one. Okay, it's now going sub negative 1200 kilometers of the altitude for the perigee, the lowest point of the orbit. Okay, and getting ready. Yeah, and looks like here at now T plus 10 minutes into the flight.
Vehicle body rates continue to look nominal. RCS thruster firings
All
continue as
right,
expected.
so that's good. What we want to hear for this flight itself. Okay,
Passing 1800 miles downrange.
all right, all right. So let's go. It's now, as you can see, the perigee altitude is already closing out.
1 minute, planned MECO.
Okay, 1 minute before the main engine cut off. Number one, I believe so. And sooner and later we will see the apogee altitude might increase. Yeah, it will increase. Apogee altitude will increase. The perigee altitude will be the real number later. So let's see. It's negative again, negative and continuously negative there. And
30
okay,
seconds to MECO 1.
okay, 30 seconds to MECO 1, engine cut off number 1. Okay, and looks like already.
This is Atlas Mission Control at
Okay,
8 plus
now
11
in the
minutes and 10
positive
seconds. We're
altitude
coming
there,
up on the end of the
on
first
the
of 3 Centaur
perigee
FSH engine
altitude,
burns.
and while
Let's
the
listen in.
apogee altitude will be increased sharply there. Okay, getting ready for the MECO 1 at T plus 11 minutes and 35 seconds. Get ready.
And MECO 1, good shutdown.
Okay, MECO 1 already shut down
Shuttle
there.
has gone to 4S mode.
All
And
right.
turning to our second burn attitude.
Okay, so it's already done, and you can see on the
Look healthy.
uh,
This will be
RCS,
toast
especially
for our second
the
burn.
We've just heard confirmation of the
especially the
successful first
mini
burn.
engines
Our
there
next event
already
is the second of 3
sort
main
of
engine
ignite
starts at L plus
to
21
ensure
minutes and
that
35 seconds.
the fuel
We'll
tank
return with mission
still
commentary as we
will be
approach that next
within
milestone.
relatable
During our
uh,
breaking commentary, we'll continue to
criteria
stream live
criteria
STK from
value,
the
so
rocket.
it's not going
STK,
to have
or
any
Satellite
problem
Toolkit,
because
is the
you need.
graphic on your screen showing where the satellite is in its mission to get to its final destination.
Oh, so we are going
The
to see,
SDK is it's using
yeah, STK satellite toolkit there. Huh? Okay, what's happening there? Okay, what's happening there? That's funny. Okay, that one essentially not coming from me. Okay, that one is actually from the United Launch Alliance stream there. I don't know what's happening. Maybe they just decided. Okay, no. You guys have to take a rest. I don't know, chill down. Oh, okay, but here we go. So far, it's still in the coast flight until at some point there. All right, so I don't know how do I actually want go and cover this one, because unfortunately we we kind of botched down on the on on few more minutes before the flight itself. Accidentally closed down my laptop, so I need to figure out a way how we are going to cover this instead. Okay. Okay. Yeah, maybe I can try this one too.
8 minutes left on this first planned coast.
Okay, 8 minutes left before the flight ballistic course there. Basically, the rocket's engine didn't ignite, and it's just going to rest a little bit just to take advantage of the over mechanic orbital mechanic law effect there. Yeah, to ensure that the fuel can be used maximum as can be used as minimum as possible while while enhancing the performance to go to the orbit itself. Basically, you save fuel, but you're doing the same amount of work work if you just like if you're trying to use if you don't even try to use the orbital
2,000 miles
magnetic
downrange.
low effect there,
Stage
and you just
parameters
keep I
continue to
think
look
it's
healthy.
basically the same,
Helium storage bottle pressure,
almost the same
battery
effect,
percentage, tank
but
pressures, all looking nominal.
without wasting too much fuel. So that's why it's very important. I think, yeah, I think maybe it's better for me to try cover some here things in there. Yeah, this is sort of my apology for botching down things. I shouldn't botch it, but maybe I can cover like this instead. I'll I'll make it interesting, okay? Uh, okay, and if I remember correctly, the inside of the payload frame itself, you see a little bit like grid there. That one is actually the aluminum alloy, okay? Just to absorb that acoustic and also the yeah, just to absorb that acoustic effect there to dampen it down so it's not going to destroy the rockets and also not going to destroy the payload inside it. Okay, and I think maybe this is my opportunity to just try amend my mistake here. Okay. Okay. I think yeah. I think I'll do this. Oh no. Okay. So okay. Okay. So why not we go and cover a little bit about this? Okay. Okay. So this one actually taken from the previous one before that, but should this one should not affect too much of our timing. Okay, and this is how the rockets looks like there. You can see this is where the ViaSat actually placed inside the spacecraft. This one is the exploded view of the rocket itself.
5 minutes to our planned restart.
Okay, 5 minutes before we start, at around T plus 21 minutes and 30 plus seconds into the flight, it should be beginning to ignite once more time. Okay, and here is the spacecraft. Okay, in this case, it's actually the ViaSat-3 Flight 2. Okay, and this one is the 5.4 meters payload fairing, and this one is payload adapter, of course, because you want to connect in between the satellite and also to connect between the rockets itself. Okay, and this one is the payload adapter ring, if I remember correctly. One of this is very important for the power and also for the telemetry purposes reason. So that's why they use this. Okay, this one cannot be touched that much.
4
So
minutes
that's
to our
why.
planned restart.
Okay, 4 minutes
Stage
left.
parameters continue to look nominal.
Okay, and this one is the Centaur upper stage, and this one like I said, this is the RL10C-1-1 engine here, and interstage adapter ISA. Okay, also another wing one I suppose there, and this one is the first stage booster. This one is the solid rocket boosters there. If I remember, in this case, it's no longer using AJ something like that. It's using no. It's now using the AJ what I'm not remember correctly, but this one is manufactured by the Aerojet Rocketdyne. Okay, and also this one is the RD-180 engines here. It has two rocket nozzles, but only one combustion chamber. Like I said in the earlier on, it's actually derived from the
3
RD
minutes
100
last two.
100 from the RD 191 rockets engine, which has four combust not four. It has four rocket nozzles there, but remain with one with single combustion chamber. And yes, it still remains one of the most
Body rates continue to look stable.
powerful single
4 minutes
combustion chamber
left.
rocket in history, and still
Battery
unmatched
bus
by
voltage.
by
Throttle pressure,
by
always
even
nominal.
even the newest rocket engines till this day. And this one we can okay, and this one we can cover a little bit because we are almost 2 minutes before the ignition of the upper stage there. Here's the ignition, okay, ignition, and then SRB jettison, pellet frame separation, okay, and then BICO, booster engine cut off. Yeah, for whatever reason they don't use MICO instead of typical one because historical reason Atlas used to call this as booster. Okay, and then later on the second stage they call it
2 minutes.
main engine. So that's why historical reason since ICBM since how do I say Atlas actually were was a derivative from the Atlas Atlas missiles itself. So that's why. That's basically for reason there, for the historical reason. And this one interstage separation, and then main engine start number one, MES one, the central upstage start, and then after that, Miko main engine cut off
Seeing
number one
expected
on the
increases
second
to
stage.
LH2 tank pressure.
Okay, getting ready.
Preparation for restart.
And then we are getting ready for this restart here on the number 8 sequence here. At T plus 2 minutes and 35 seconds, we are going to be ready. And then it will cut off, main engine cut off number 2 around 26 minutes
1
and
minute to
55.4 seconds. And after that, third main engine start, the MES3 will commence around T plus 3 hours, 26 minutes and 55 seconds, something like that. Point 1, and after that it will cut off less than 3 minutes or 2 minutes plus like that. Main engine cut off number 3, and then spacecraft separation, and then ignition again. Okay, so let's go back to this one here. Wait, yeah. So yeah, let's go again.
LH2 pre-start.
Okay, getting ready for LH2 pre-start, pre-bonus start. Okay. Okay, so get ready.
And LO2 pre-start.
Okay, pre-bonus start already happened on the LH2, the liquid hydrogen, and getting ready. Ignition.
Ignition.
Alright,
And
ignition. Full thrust on the main gen start number 2, and now it's going to rest the
Steering wheel.
orbit
Body rates responding accordingly.
to around
This will be
20,000
just over
plus
5-minute burn.
kilometers of altitude, or 30,000 kilometers plus altitude, something like that. So this is what the this actually functions for, using the orbital magnetic law effect there. It's going to raise up the orbit just using minimal fuel as much as possible,
Parameters to
but
account.
you maximize the
Body
mission
rate control.
efficiency just by ballistic costing phase and then ignite at some point, and then it will ignite once more
Fuse
around
gun to closed loop control.
3 hours plus from now. But I'm not very sure if they are going to show us that more on the insertion. On the insertion, I'm not very sure, but yeah, that's very interesting. You can see there, or maybe not. I don't know. But right now, the apogee altitude is 2,000 kilometers,
Vehicles passing.
and
53
perigee
miles down.
altitude is just slightly increased to 166.72 kilometers. Okay, so
Engine parameters responding to
looking pretty good.
hydrogen correction from PU. All responding nominally.
All right, all responding is pretty nominally.
4 minutes left in this burn.
Wait, how's it? How many minutes left? Okay, under 4 minutes burns left before shut off, or cut off before the main gen cut off number 2, and getting ready. And yeah, regarding what I said earlier on about this laptop, well, I'm going to replace it at some point because, as you can see, even the OBS itself, I can say the performance is not really the most acceptable in this current, especially with what I'm doing right now with streaming, making video and whatnot. I can say it. I rather just go and finally upgrade my laptop. I mean, not like upgrade the components. No, it's like completely replace the
3
laptop
minutes
because
to MECO 2.
it's not really the most reliable nowadays. Yeah, it's literally living hanging by its own thread. So okay, 3 minutes left into the burn. Okay, you can see how the orbit orbit raising maneuver actually done here and there. All right, all right, and looks like the burn is still nice and good. Okay, all right. So here we go. While we are talking about that,
2 minutes to plan MECO.
okay, 2 minutes before Miko 2. Okay, why not we talk a little bit here? If I remember correctly, most of these rocket construction there, they're using something like, they're using, oh no, oh no, what's happening? What's happening? Oh, fortunately it survived. Okay, I'm a little bit afraid.
Passing 6,000 miles downrange. All parameters continue to look nominal.
Okay, so from what I know is that most of the no, please don't watch, please don't. Oh man, let's not crash it. Come on, don't be a spoiler. Don't be a mood spoiler, please. Please, I'm not asking too much.
90 seconds left in this burn.
Okay. Okay, around 90 seconds and getting ready. What we are talking about that? Why not? We talk a bit. The construction, from what I know, is that it's actually built from the from basically like from alloy, something like that.
30
The
seconds to MECO.
here, but I'm not going to pretend to know everything about the topics, but basically it's like alloy something for the construction build and getting ready for the
Use return
Miko
to the loop.
2, the main engine cut off number 2 happen. Oh no. Ooh, that's terrible. I think almost Miko 2. Alright, getting ready. Miko 2.
And good shutdown. MECO 2.
Alright, and good shutdown. Miko 2
Is
already
soon
comments.
100% and
Main
expected.
engine cut off
Body
number
rates
2
respond.
already confirmed. And then the last one would be the Miko, would be the main engine start number 3, and then later would be the Miko number 3.
Attitude.
That one will happen around T plus
And
3 hours plus, like that, almost 4 hours from now. So yeah. Okay, so looking from the live mission progress, I think there there is possibility this stream might actually end it here. Yeah, I believe so. It might end it sooner than later. Alright, it's already ended. So yeah, thank you so much everyone for watching. Yeah. Yeah, unfortunately the stream has already ended there. So yeah, I guess so, but why not we go straight or infiltrate Cat Blocksworthy stream once more time? Okay. I hope she's fine there. Alright, so that's practically it. Already ended on that. And fortunately it was launched at the right precisely at the first window launch hour. So not much else they have to do. Alright. And let's go wait her stream once more. Infiltrate her stream once more. So yeah, this is if I have to use standard English coding. Yeah. Alright, Taran Zero, thank you so much for your comment. And yeah, thanks. You said thanks for the stream. Yeah, you're welcome. Thank you so much. It's not really super duper good, but I think it's better for us to just end this stream. Internet reception is not really the best right now. So thank you so much for watching. Take care and goodbye everybody. And also I need to tell you, this mission is actually the last mission I ever able to go to the geostationary Earth orbit for the Atlas rocket series as a whole. So I guess we say farewell to the Atlas rocket series era beyond low Earth orbit, and also at commercial customer there. I said that aside from Boeing Starliner and also the Amazon Kuiper satellites constellation, this one I can say is completely the last two commercial customers. Beyond these two, we basically just stuck on the low Earth orbit, and even then it's not going to be as exciting as the launches we have right now. So yeah, I guess that's all. Thank you so much for watching. Take care and see you guys next on the next stream. So bye bye. And also, if you're new and existing viewers, I really appreciate that you really come here. But for those of you who actually missed this stream, well, don't worry, you can watch the replay later. So that's all. I'm not going to talk too much. That's it. Bye bye. Take care. And let me leave some comment for Parent Zero, because why not? But that's the good thing I can do, is to appreciate your time for coming to this thing. Alright. Or I don't know, maybe I can stop stream for now. Because seriously, I really want to comment. Oh! Okay, maybe I have none. Okay. Okay, yeah, fortunately I have the comment here, so thank you. Yeah, so yeah, I've heard. Okay, never mind. That's my another channel. Never mind. Maybe I'll try something else. I guess. How do I do this? Maybe this is okay. Thanks for watching. No, thanks for tuning in. Appreciate it. Okay. Yeah, so that's it. You get a good comment there. Yeah. So thank you. Thank you so much. Bye bye. See you on the next stream, and also you can watch this again on replay. Bye bye.